Next example is also a trig example, but a little bit more complicated integrand. You can see that I have cosine to the fourth and sine of x. So here it's the cosine that's raised to an exponent, so that would be my first try at u. Alright, and then I take the derivative, so du dx is the derivative of cosine is negative sine x. So du is negative sine x dx. Alright, so you see that I can write this integrand now in terms of u. I have my u to the fourth, so that takes care of cosine, and I still have sine x dx. So notice here I have a negative sine x dx, so I'm going to divide by negative 1. So now I have sine x dx is equal to du over negative 1. So the sine x dx is replaced by du over negative 1. I'm making just a substitution for sine x dx. Here I have that. And then that negative 1, obviously dividing by a negative 1 is just like multiplying by a negative 1. So I can factor that negative 1 out. And this is my new integrand. So I have everything written in terms of u now. And again, now that I have it written in terms of u, I've kind of done all the hard work up front. And now this is a really easy integrand, or a really easy antiderivative. So I have u to the fifth over 5 plus c. And then I had u equals cosine x, so I have cosine to the fifth x plus c. Alright, so the next one I have secant of 5x, tangent of 5x. Alright, so that is really close to the end result of a derivative. Right? So I know that if I take the derivative of secant, I'll get a secant tangent. So all I really need to do is take care of this 5x part. And so I say, okay, well, u is equal to 5x. So du dx equals 5, and du equals 5 dx. So I can write this integrand now as secant of u, tangent of u. But notice here that the only part now that's still not represented in terms of u is the dx. Alright, so I don't need a 5 dx, I just need a dx. So I'm going to divide both sides by 5. So now I have dx equals du over 5. So this du is going to be replaced by du over 5. Du over 5 is like 1/5 times du. So that 1/5 comes out in front of the integral as a coefficient. And now I just have secant u, tangent u, du. That's the end result of the derivative rule we talked about earlier. So the antiderivative of that is just 1/5 secant of u plus c. And then again, I have the u here. U is 5x, so to finish off the problem, I make it 1/5 secant of 5x plus c. Alright, last example. This is a trickier one. So here I have x times the square root of 2x plus 1. So I'm going to let u equal 2x plus 1. That's the innermost part of the function here. And then my du is going to be 2 dx. So as I start to do this substitution here, I have the square root of u here. Alright? And notice here that I have a dx and an x that I still need to represent in terms of u. And I can't really represent this x using the u that I have or the du. The du is just a 2 dx. So we're going to be able to use that for the dx, but not for this x part. So I need to figure out some way to represent this x in terms of u. And so this is definitely a harder problem. And the solution that we're going to come up with is to use this equation and solve it for x. Right. So now I have this x is equal to u minus 1 over 2. So this x here is going to be u minus 1 over 2. And then the dx, just like I did before, I only want to replace the dx. So I'm going to replace the dx with a du over 2. So in this case, just to summarize, I have square root of 2x plus 1 using this u substitution here is replaced by square root of u. The dx itself is replaced by a du over 2. But I still have this x that wasn't easily represented in terms of u, just with my u and du. So I had to take my equation for u and solve it for x, and then use that u minus 1 over 2 to replace the x. So now I'm going to clean this up a little bit, and it's going to look like this. So this, what I did in this step was I just took this divided by 2, factored it out as a 1/2. So I still have the u minus 1 over 2, I still have the u to the 1/2 here in the du. Right, now I have it all in terms of u, but I still want to clean this up a little bit more. So my next step, I'm going to take this divided by 2 out here. So the 1/2 becomes a 1/4. And then I'm actually going to distribute the u to the 1/2 here and here. So u to the 1/2 times u, I add up the exponents and get u to the 3/2. And then, of course, u to the 1/2 times 1 is just u to the 1/2. So now I have this really easy integrand. I can just add 1 to each of the exponents and divide by the new exponent. So it looks like that. I probably could just leave it like that. In this case, I decided to distribute this 1/4 to the 2/5 here and to the 2/3 here. And of course, I finally wanted to substitute that 2x plus 1 back into the expression for u.